So magic is real. And not only will I convince you that magic is real, I will actually teach you. I'm going to teach you one of the most basic and easy spells to learn. Dark vision, or the ability to see in the dark. So, under a very specific set of conditions, fairly common conditions, but a specific set of conditions, you can perform a hand gesture. I can see some people, isn't this an OpenSearch talk? You can perform a hand gesture and then greatly improve your ability to see in the dark. For real. So, you make sure you got a little bit of room. You got to move some hands maybe here. Maybe you got to move some hands. But all right, perfect. We're warming up a little bit. Are you ready? You ready? It's the easiest spell to learn. You ready? Thank you. With one hand gesture, you can magically see in the dark. So that is a value. We call that a value, the ability to do something. And a feature is how that happens. And so the feature under this is 120 volts of electromotive force goes along a big conductive line, and you close the circuit, you close the light. That's very French-Canadian. You close the light. And then after all of that, a bunch of photons fly over a bunch of diodes in a modern light bulb, and then light comes out of their behind, and that's the feature. That's the technology behind that. The value is a hand gesture to see in the dark. The feature is all of that electromotive force. I'll say it a little easier. You connect enough magic rocks and light comes out. And so the feature underneath is connecting magic rocks so the light comes out. The value is a hand gesture that lets you see in the dark. And my teams are well aware. I talk about this all the time. I really try and reinforce engineers and those that dive deep into the technology are often very in tune with the features, but sometimes lose focus on the value, what it creates on the other end. And likewise, those that are dealing with the business side, the outcome side, they're really focused on the outcome, but not always the features or the technology or the wizardry that goes into making it happen. And so we try to combine those two. There's actually one more even cooler outcome that we'll come back to in a second. But first I'll tell you a little bit about who I am. Hi, I'm Abe. I got my start in IT a very long time ago in rural Canada selling books for an independent bookstore. We were pretty much about to go bankrupt, and then we started using this website that nobody in rural Canada had heard of in the late 90s to list some books for sale, and that kind of saved the bookstore. And from there, I ended up joining the military, and I worked around from them for a few years. I only really, and still only really, have two employable skills. I was pretty good at breaking into computers, and I was pretty good at explaining things to people. And so to this day, that's really the skill set that I leverage. And when I did the several years in the military, that was how I spent most of that time. After that, I joined one of our bigger cities, and I became the head of security for one of our bigger cities in Canada. Most of my time was spent explaining, because if anyone's worked in local government, you know that's about all the budget you have, is to spend time talking to people. What was interesting about that, though, is I learned as a security person, you always want more firewalls, more antivirus, more of all the things that do all of the security stuff. But what's interesting is when you're fighting that with tax dollars for building nicer parks or improving schools or firefighter rescue systems, you end up learning a lot about risk management and what really matters to the core of the business. So I learned about that along the way as well. And then after all that, I still combine those skills, and now I'm the VP of Customer Enablement at Graylog. Before I hand it on, this is my friend Rick and his background.
I spent 16 years in municipal government.
Can't hear you.
I spent 16 years in municipal government.
Thanks, Rick. So before he takes any more air out of the conversation, I want to go back one more thing. We've got those features, the magic rocks that turn into lights. We've got the value, which is how I see in the dark by flicking my finger. When you combine all of those, you can get to a certain number of features, a certain number of values, and you can get a fairly complex outcome. I like the term complex outcome. People that deal with money like the term business outcome. And my favorite example of a complex outcome, of combining a whole lot of features and values is, it's actually another light, but it's when you take about 100 years of combustion engine science and 50 years of diagnostics, sensors, predictive behavior modeling, pressure sensors, warning indicators, and all of this stuff. And you build an encyclopedic knowledge of how vehicles and cars work and what can possibly go wrong with cars. But you, as a customer or a consumer of a car, can't be trusted with that. I can't be trusted with that. We get an emoji. So when you take 100 years of encyclopedic knowledge about cars and combustion engines, it gets all the way transformed into one outcome. You need to take this 2-ton latte transport machine to the car doctor. That's what you get, an emoji. So with all of that said, Rick's going to now identify some of the features we're talking about, and then we'll come back and put it together a little bit more too.
Thank you. I'll use, but I have this mic. Thanks, Abe, for the incredible intro, combining the powers of magic and science. Welcome to We Love OpenSearch, so you don't have to. Who is the we? Abe and I have traveled from the far-off land of Ontario, Canada, not California, to be here representing Graylog. I'm Rick, and I promise everything I said in Abe's intro was 100% true. I am part of Graylog's professional services team, and we work with OpenSearch a lot. We deploy it for customers. We scale it for, well, customers. And we find problems, and we fix problems that customers have with that product. So other people that have spent a bunch of time working with OpenSearch probably know how incredibly complex it can get. And it gives you enough rope to leave yourself hogtied and very confused as to what you were doing with the product in the first place. The upside is, I mean, it's incredible at just being able to hold all sorts of types of data and make that data indexable, searchable, and otherwise analyzable. I'll be breaking this part down into 3 major sections. The basics, where we talk about things like document storage and search language. The middle, talking about configuring the indexes and visualizing the data. And the cream of the crop, detecting anomalies and searchable snapshots. Each section will hopefully build upon the last of them. So let's talk about some of the basic stuff of how Graylog enhances OpenSearch. And I really love this graphic. Thank you, ChatGPT. You'll see it a lot. So document storage. This one's going to be a bit of a big one because it's a very fundamental part of OpenSearch. At its core, everything stored in OpenSearch is a document. It's document storage, though it has no rails. You can put pretty much anything into a document as long as you can get it into the system. So what is the royal we storing inside of OpenSearch, and how do we make use of it? Well, Graylog's use case focuses on storing log data. That is our prime business model. That is what we do best. So we act as a middleman to get your data from your various sensors, applications, magic security boxes, and everything in between into OpenSearch. Unfortunately, there's no all-encompassing log data transmission protocol or format, so you benefit from having something that can receive, process, and output all that log data to OpenSearch. So when your firewall speaks the common event framework, and your application outputs as log4j, and your NTP clock outputs syslog, and your espresso machine starts speaking Mandarin, you can get that log data into OpenSearch as documents. Once the data has been received by Graylog, it can be decoded and processed if needed. There's several ways to perform this processing, but our most powerful method is pipelines. Pipelines are multi-stage rules that can be used to slice, enrich, delete, and otherwise manipulate your data into entering a pipeline. We have some recommendations for normalizing your log data called the Graylog informational model, which helps you take something like this, absolute rubbish, nobody wants to look at those logs unless you really like using grep. And we convert it into something like this. Now, this looks like chaos defined because there's a lot of data in there, but we add more fields because it helps with indexing, it helps with searching, and it helps with categorizing that stuff. So during it, we add a lot of metadata. The most important ones in the Graylog ecosystem would be streams. They're a great idea. Oh, wait, sorry, I gotta load an image here. Oh, thank you, thank you. Perfect. Streams can be used for simple data organization, such as categorizing your firewalls into one stream or grouping all Windows servers into another stream. They're also used for security purposes inside of Graylog. You can restrict users or groups to retrieve only the information they're assigned. The last major feature we use for streams is to ensure that documents are routed into the correct indexes. Indices, whatever, I'm not the grammar police. Oh, sorry, we have to load another image here. Okay. OpenSearch indexes are flexible as long as you follow the rules. For example, who knows how many fields you can have in an index by default? Does anybody? Please yell your answers. Thank you. The answer is 1,000. Now, how many fields can you generate from a XML file from a Windows security event log? Well, sometimes it's more than 1,000. So Graylog bundles those indexes into index sets to optimize around those rules and improve performance and flexibility. During all the document storage operations, all the data is still stored in OpenSearch, but from an end user perspective, they haven't touched OpenSearch itself. And we do this because we love OpenSearch, so you don't have to. I promise it's the last time I will pull that gag out. Now that I've talked about getting some data into OpenSearch, the best part is getting your data back out of OpenSearch. And the best way to do that, search language. Because even robots can't do JSON. Let's ask ChatGPT. Yeah, that's not JSON, ChatGPT. So personally, I'm not a fan of writing JSON for querying data. And if you're a security analyst, you're probably also not that keen on it either. So we abstract that. We use a simple query language for searching that's plain text-like with advanced features. It allows a variety of queries without worrying about the braces, the quotes, the commas. It's very similar if you're familiar with the query string query language or the dashboards query language. So we have things like this, a basic query. You have 2 words that you typed in the search box. You get all your firewall logs back that denied somebody. Then you can go a little bit more advanced. You can search for specific fields like the HTTP response. You can get all your success codes from 400 to 499, and you can exclude in this case, we can do some negation. We can exclude a host. Maybe that's your monitoring system. Maybe that's some other device that you know is a problem and you just want to get rid of it so you can see the rest of your data. And then finally, if you're truly twisted, you can do regular expressions. And if you play our CTF on Thursday, you might have to do that. Spoilers. The attendance information, by the way, is on the back of your badges, so I hope to see every single person there. The search queries themselves, they're limited mostly by your imagination and the structure of your documents, so you need to make sure to have some rules to structure your documents. In the case of document structure and rules, Graylog supports custom OpenSearch mappings, which can be applied to an index set to prevent things like having numbers in your assigned string types, like keyword or text. You can also use it to reject bad data so you don't end up with your host names and your IP fields. And in this case, like, we have hot dog data. That's pretty important data to gather. And I mean, you just can't eat all of the hot dogs. I'm sorry, that counts. And you can't have 9,000 is not a text field in this case. We don't want this. So we apply index set and field mappings, and we turn that information, and we clean it up. We can say, hey, that's supposed to be an integer. And now we have 9,015 hot dogs, which is exactly the amount of hot dogs you should be eating. Don't eat that many hot dogs, please. So that was kind of the basic stuff. So some of the that was our foundational stuff that we do with the OpenSearch documents. Now that we've talked about that, let's talk about some of the more complex configurations that we provide in conjunction with OpenSearch. Like configuring your indexes. I think that's fairly accurate representation of once you get to the nitty-gritty. There, you can see all sorts of pseudo words there with sizes and shannix and replicate sizes and shard shizzes. So I mentioned before, the indexes are flexible, they're powerful, but there's best practices associated with them. You should keep things like having an index shard size of 20 to 15 gigs per shard for optimizing your performance. Graylog itself allows the configuration of indexes bundled into index sets via the Graylog GUI, and we allow you to configure things like your shard counts, which is important when you scale beyond a single node and into very large clusters. Replica counts, which are important for the reliability of your data and optimizing read performance. Index rotation, to keep your shards optimized, we have a bunch of different rotation options. You can do things like rotate every X number of messages, which is good if your data size is all the same and you have fixed rows in which you know that you're going to keep your data aligned. We can rotate by size. We can say, hey, we want to rotate this index every 50 gigs, which is great for keeping your performance up, but it's terrible for maintaining your retention periods. If you have one day where you generate 300 gigs of data, that could blow out your 30 days of retention, your 60 days of retention, your 1 year of retention completely out of whack. We can configure rotations by time. So rotate once a day. It's good for keeping your retention of data, but it's terrible for performance. If you have 200 megabytes of traffic one day and 200 gigabytes of traffic the other day, your shard size will be out of whack. And then finally, we have Graylog's secret sauce, which is called index time size optimizing. It guarantees your retention periods, so you can keep your 60 days, 90 days, whatever amount of retention, and you keep your shard sizes at the optimal size. So you're guaranteed to have your retention periods without sacrificing any performance. And then finally, what do you do after you've hit your retention period? Well, we allow you to configure archiving, which allows you to keep your data longer than that, and I'll touch on that a little bit more on the next slide. Combining all those, we get to manage how your documents go into indexes while keeping them healthy and performing well without a lot of JSON. And since nobody likes configuring these every time you create a new index set, Graylog in 6.1 will be having a new feature to create templates so you can templateify your indexes. So if you have an application that you want to always have the same retention, you can create a template for that. You have firewalls, a new firewall type, you can template that. It helps you meet your compliance goals. As mentioned about archival storage, what happens when you hit your life cycle of your data? Storing data live in OpenSearch can be expensive. If you had an unlimited budget, maybe you could handle that. But if you don't, like most people, you want to offload some of that data. But you could have compliance requirements. If you're in a financial sector, you might have to hold transaction records for 2 years, 7 years, longer. Graylog offers the ability to archive the indexes to a file system or an S3 compatible bucket to save capacity while keeping your compliance goals in check and enabling you to fully rehydrate that data back into OpenSearch and have it searchable again. You can configure those all in an per index set level so that you can have transaction data for a longer period of time than something like your debug logs, which maybe you don't want to archive at all.
Can I jump in for a quick second there, Rick?
You may.
So, this is off now.
I turned it off.
Oh, you did turn it off.
I'm a professional.
Maybe that was smart. Now, if I just ask people to raise their hands, nobody ever participates, so I'm going to go the other way around here for a second. Everybody put your hand up for a quick second. Everybody put your hand up for a very quick second. All right, awesome. Now lower your hand if you've ever had to deal with shards, replication strategy, or indexing strategy. So lower your hand down if you've ever had to deal with that. All right. So the people with their hands up are the ones that have never had to deal with that. So everyone else, I know I made that very confusing on purpose. Everyone else has had to deal with that before. If you haven't, it's quite a wild phenomenon. Basically, you have like a 3-variable problem. The amount of shards and like the quantity, the size, and that's because that's a huge impact on performance, and how long. Because let's face it, in security in real human world, nobody says, no compliance in the world says you need to keep 50 terabytes of logs. Or no accounting firm says, we're going to keep 100 terabytes of accounting logs. No, they're going to keep 90 days worth, right? So you have this entire problem of how many are there, how big are they, and how long for. And that 3-body problem, for lack of a better word, great series, by the way, if you haven't seen it, also a fantastic book. So that 3-body problem is actually a really challenging math problem. And I know there's a couple of people here that have worked on this at both OpenSearch and Graylog and can attest it. So what Rick was talking about there, and then adding on the archival at the end, that index series optimized stuff, that is some cool tech. It's one of those like sleeper techs underneath the hood that is like, to do this and not suck is really hard. To do it and suck is easy. To do it and not suck is actually really hard. And it's a really cool problem and a really cool problem to solve and a very cool technology under the hood that is possible from some of the features of OpenSearch. So awesome. Sorry, Rick, I just wanted to jump in there.
No problem.
I love that feature, by the way. It's cool. All right, Kerry, go ahead.
All right, so we've arrived at the check engine light part of the presentation. And we have a lot of different sensors. We affectionately call them widgets. So everything here is powered by Graylog searches data stored in OpenSearch. And that means that the data can be retrieved, processed, visualized, alerted on in the same tool. Want to see what data is coming from the visualization in the widget? You click the play button, which I kind of missed. I think I can, I don't think I can do that on here. There's a play button on the widgets. It allows you to get the raw log data that you came across. So you can see the raw data that's actually stored in OpenSearch, and you can narrow it down, get further insight on that. And finally, we've reached the cream of the crop. Let's talk about the most advanced features that OpenSearch contains that we use inside of Graylog. And you can't mention the cream of the crop without bringing Macho Man Randy Savage into it.
I thought that was a picture of you when you were younger.
It was way more handsome then, too. So finding weird data in your system is often hard work. Things like data exfiltration, arise and failed login attempts, mass file deletions are threats that are difficult to detect. We use OpenSearch's anomaly detection plugin to monitor for threats like these by trending log activity without knowing the deep details of run-cut forest and utilizing a much simplified query definition. So you have data like this, and we can see that that data is probably bad. We also implement an optional warm tier using searchable snapshots. The idea is that you can store your hot data for recent search activity or most commonly used search activity in your expensive NVMe disks, and then put your long-term stuff that you still need to search. Maybe you need to generate a report for the CO once a week, once a month, and you can put that on SATA storage. Have that available. The last feature that I'm allowed to talk about that's coming in Graylog 6.1 before Rich jumps on stage and beats me is simple clustering, or as we want to call it, data node. The goal of this is to wrap OpenSearch in a neat little bundle that allows tighter integration within Graylog by including automatic security certificates, built-in metrics and monitoring, so you spend less time configuring OpenSearch security and more time analyzing your data. Now, I spent a lot of time throwing shade at JSON, and guess what? If everything I said didn't convince you, then please accept my JSON formatted apology. And with that, you can use all your JSON skills to configure everything I've talked about today via the Graylog API, which takes JSON. And that allows you to implement or integrate that with your own systems and processes. It's Graylog driven by you with all the features of OpenSearch. And now let's talk about some of the cool results we've done with everything I've talked about. If you want to. Yeah, sure.
Awesome. Thank you very much for that detailed look, Rick. So how does this all come back together? How do we make a check engine light out of this? Again, that's our goal. Our goal is to provide check engine lights for security analysts. Security analysts look more like me than an average OpenSearch engineer, and that's what we want. That's why we exist, is so that we can do the data part for them and they can do the security analysis side. And that's their specialty. They know exactly which Windows events to look for and which ones are anomalous, and that's a different skill set, and that's who we build for. So one of our first ones that we like to talk about is mostly a security use case, but also is part of their operational. And what they are an online gambling site. And so they provide betting for different types of things that you bet on. And I didn't ask anyone's permission to do these case studies, so everyone's generic. But so they do online betting, and that's super cool. What it means, though, is when there's some sort of event coming up, monumental amounts of burst traffic. Huge amounts. They're big. And so anyone who's tried to do things at scale, especially when you have complicated systems such as clusters, nodes, and then you have lifecycle management on the back end, scale is hard, burst scale is even harder. And where it really matters is stagnant stuff. So your data center sitting there, or even your EC2 instances, sorry Amazon, sitting there, being paid for not doing anything, cuts into the bottom line big time. And so what we had to try and do is handle this huge amount of burst data that was mission critical, so very time sensitive. One way to handle that is to slow it down. But if it's time sensitive, that matters. And so we had to keep it time sensitive, high performance, plus gambling is fun, so it's a great example. So in the end, the features that we had on that were some of the features that Rick talked about. So that was, I'm going to kind of time, so I'll be a little quicker on some of these. But the features were some of the features that Rick talked about, where we had the fantastic scaling, basically the magic rocks that turned this on were that index time series optimization, the index configurations, and the document storage pieces that he was talking about. And how do we do it? We added on the Graylog value of our message processing, our queuing and buffering, and the capability of transforming the data and spreading that out a little bit better. What that allowed, it allowed a very high performance gambling site to keep taking your bets and hopefully get some money. Number two is a cool fintech company that has survived a whole bunch of M&As and a whole bunch of acquiring and has like a unique competitive advantage in the sense that they basically operate like over 100 individual business entities. And so when they're trying to do an oversight on their data and their information, we end up with this massive problem of how do I deploy hundreds of OpenSearch clusters, hundreds of Graylog clusters, and then try and still have them competing with this business unit, and that is their competitive advantage. And so we had to get deep into cluster health materials, lifecycle management, stuff like that. The value that we added, things like archiving and the particularly multi-threaded archiving, streams that we talked about, which is the role-based access and permissions for those indexes and that data. And we were able to layer that on top to operate with hundreds of individual business units, the right people seeing the right data at the right time, and still maintaining some level of disaster resilience and those kinds of things behind it. And they can keep their competitive advantage in their fintech space. Again, we can talk about all these in a lot more detail if you want. Catch us afterwards. And number C, part number C, this one is pretty unique. And this one we just titled Creepy AI Camera Stuff. So those that are aware of brain rot and hear kids saying Skibbity, this is a character from Skibbity. But anyways, what this one is a small business or home level security surveillance system, such as cameras, ring type cameras, Nest type cameras. And if you have the right data types and just good old fashioned functionality of OpenSearch, a lot of those cameras now have AI descriptions of what's going on in there. So if you do some text processing, such as what Graylog does, and you do the text processing on kid with ball, dog with toy, and you're seeing that in your camera, now you could start overlaying some pretty interesting data of, well, the kids were playing outside from 2:27 to 3:05 p.m., and the dog actually ran away last night at 6:38. I didn't notice he was missing till this morning. And so you get what I called the lazy babysitter analysis, but you get it for 24 hours right across. So you get all the cool information, the feedback, and then when you lay that on over data tools, it actually can be some pretty interesting stuff. And just because we got a few seconds left, I added one for bonus content as well. And this one's a little interesting. It's a big household financial name that a lot of people have heard of, but you get, okay, who's ever worked with customers? Who's worked with customers? All right, so we got a huge household name of customers, and nobody can probably ever relate on this, but they insisted on having what we'll call a high availability architecture. They insisted on having, we want our stuff to be able to survive outages. Fair enough, that's a very common request. Here is the architecture for surviving outages. And they look at it and go, okay, well, what do you want? Do you want to survive the outages or do you want to follow our architecture? No, both. We want to survive outages, and every time you give us this architecture, we're just going to, no. Which is fine. The vast majority of companies that do that are like, yes, we really want all this latest and greatest, and we want all of this, and this is cool, and I think it's awesome, especially when it comes to disaster and HA and that kind of stuff, are also the same companies that never, ever test it, so you don't really care. And they're like, yeah, we want all the HA test, but then they don't test it, and so, everyone's happy. Well, these ones, they want the HA, but they actually test it too, and they never follow our recommendations. So the customer's always right, except for when they aren't. And really, the only thing is, they insist. We have 2 data centers. We have this data center, big giant one here, this data center, big giant one here. Okay, you need a third. For HA, it can be a $50 Amazon instance running in monitor mode that just settles arguments when one goes down and the other one doesn't. That's all you need. No. Okay. So, through a whole lot of cleverness on cluster health and load balancing, we did end up creating a check engine light that took a massive amount of resources that could have been solved by probably a $50 Amazon box. But we solved these massive amount of resources for this customer that always insisted they were right. So that was my bonus content on that one. So, a little bit more on how we added that all up. Anyways, this is it. That's thank you very much, everyone. The call to action is come check out the Graylog CTF on Thursday. We're giving away a Steam Deck as the prize, so come check that out. I'd like to thank Rick for bringing me up here. And hi, I'm Abe. There's our details there. So thank you very much.